If you jumped out of a spaceship and fell straight into Jupiter, about 11 times wider than Earth, you would never ever hit the ground. Not ever. Here's the wild thing. Jupiter has no solid surface at all. It likely formed around a solid core of heavier elements that then gathered immense amounts of hydrogen and helium, which now constitute the vast majority of Jupiter's mass, though their physical state changes dramatically deeper down. Jupiter is made of about 75% hydrogen and 24% helium by mass, corresponding to roughly 86% hydrogen and 13% helium by number of atoms, with the rest being heavier elements. The same basic ingredients as the Sun, just not massive enough to ignite. So what do you actually fall through? Picture it like diving into a planet-sized ocean of gas, initially encountering thick, opaque clouds that just gets thicker and thicker the deeper you go. Layer 1. The cloud tops. Winds here hit 500 kilometers per hour. That's faster than any hurricane on Earth. You'd be shredded before you even got started. Deeper in, the atmosphere gets so thick and hot, reaching thousands of degrees Celsius, that gas quietly blurs into liquid. There's no splash, no surface, just gas becoming liquid, molecule by molecule. Here's the curiosity gap I promised you, far below the cloud tops, starting around 10,000 to 20,000 kilometers down, or roughly 50,000 to 60,000 kilometers from the planet's center. Something insane happens. Hydrogen stops acting like a gas or a liquid and starts conducting electricity like a metal. This is called metallic hydrogen, and it only exists under immense pressures, reaching millions of times greater than Earth's atmosphere, starting around 1.4 to 2 million times Earth's atmospheric pressure. Think of squeezing a balloon so hard, the air inside starts acting like copper wire. That metallic hydrogen ocean is what generates Jupiter's magnetic field. Its overall magnetic strength, or magnetic moment, is about 20,000 times greater than Earth's. It's one of the largest structures in the entire solar system, second O.